My name is Linn Sidahl. I'm Head of Business Development at Ekkono Solution. Last Open Fika was 2 weeks ago, and it had a tech focus when our CDO, Rickard, and machine learning engineer Thomas talked about incremental learning, which is a unique feature of Ekkono. And in this week's Open Fika, we will focus on another unique tech feature at Ekkono, which is energy efficient machine learning algorithms. And that's why I asked our data scientist Eva to join this week. But before we get started, a few rules of engagement for this week. So as always, you're all on mute. So if you want to give a comment or speak, raise your hand and we will unmute you. And if you have questions for the presenter, me and Eva, use the Q&A function. And if you have practical questions, use the chat function, because we have Elinor who's dealing with that. So use the chat function if you have any practical issues with Zoom. And let's get started. Before we started today, I think that you all saw a quote. And I would like to start reading that quote. So, the Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. And Carl Sagan said this 20 years ago when he really emphasized the importance of Earth. The Earth, which is our home, is which we now fill with 7.6 billion people, even more cars, and last but not least, 50 billion connected units. Keep that number in mind because that's important. And why is this important? Well, I would like to raise two aspects of it. First, the Earth, which is our home, is experiencing a climate crisis. At Ekkono, we believe that new technology will be key to face the crisis, and innovation speed is higher than ever, as we all know. And therefore, we need to start considering the environmental impact of new technology as well. But it's not only about sustainability when it comes to energy efficient machine learning. The other aspect is of course the practical one. Will it even be possible to connect everything, i.e. 50 billion units, and run machine learning or AI on it? Do we even have the amount of processing power and memory available? The solution could be to develop more and more powerful processors. We'll need to do that too, for sure. But in this Open Fika, we want to focus on a solution we suggest, which is energy efficient algorithms. In other words, if we want to save the world with new technology, let's start looking at a solution that's even possible. And this is why I invited Eva to join me today in this webinar. Eva, you recently did your dissertation on this topic. Can you give us some background to your research and why did you become interested in green machine learning in the first place?
Sure. Hi, Linn, and thank you for the invitation. So I think this is I'm really happy about this Open Fika because it's going to be like a really easy conversation between me and Linn. And hopefully you will get to know us a little bit better and you will get to know green machine learning and be excited about it as much as we are. So a little bit of background. I recently finished my PhD in January this year. And I did it in Blekinge Institute of Technology, the university in Karlskrona. And during those years, I researched how to make machine learning algorithms more energy efficient. I work mostly with online decision trees that I will explain a little bit later. So why energy efficiency? And the thing is, when I started my PhD in 2015, most of the research was, and still today, to be fair, on how to build algorithms that are really good, really accurate, that can beat the newest record on detecting cats and so on. But then I realized, wait, what about the energy consumption? Like, if I want to run this algorithm in a small device, can I do that? Well, the answer is now, yes, not all of them, a few of them, but back then, not really. So we don't have a lot of devices that have 1 million GPUs available to be able to run all of these expensive computations. Or if we have an electrical car, we don't have a battery that can sustain that many computations. So that's when I thought like, okay, why don't we push this idea of green machine learning forward and try to build machine learning algorithms that are sustainable and energy aware. So that's more or less the summary.
Okay, and a little bit about the research itself that you did. What were your main findings?
So I focus mainly on streaming data. Streaming data can be seen as the data, for example, from sensors or any device that is generating data in real time. Traditional machine learning algorithms assume that you have all the data available, and then they build a model based on that. In our case, we are building the model when the data arrives. And the cool thing is that we build the model incrementally and we don't need to store the data. This is very nice because we don't need like all these huge servers to store that data. And also we don't need to deal with, you know, GDPR and all of that. We only need to save statistics of what we see, like means, to put it simple. And then we throw away the data, but we keep the model that has learned from that. So moving back to my research, I was trying to answer one fundamental question. That was, how can we construct machine learning algorithms that learn from streaming data in a more energy efficient manner? So at the beginning, we focused on how can I measure energy? Then how do these algorithms consume energy? Because, I mean, at the beginning, you don't know, right? And then like, how can we make them better?
That's interesting, and I think that many of us that are listening are thinking about in which type of use cases or which type of settings could this be applicable. So we will talk about what you think, Eva, but I think it would be interesting to see also what the audience think about it. So Eleanor, would you mind sharing the poll? So here we want to ask you a question, and it's basically, what type of applications do you think are most suitable for energy efficient algorithms? And you can choose multiple answers. So we gave you the options of tiny devices, industrial machinery, big server rooms, electrical vehicles, all the above, or other. So I see that 3 have voted now. Let's give it some time so everyone have time to think about it.
Nice. Yeah, I think, I mean, you can choose whatever comes to mind first. There's not right or wrong answer. It will be really interesting to see, I don't know, what everyone thinks about it.
Exactly. There are still a few left that hasn't voted yet. Let's give them a few more seconds and
yeah.
Did you have this in mind when you started your research, Eva? Or was it more about how to actually construct the algorithms, or did you think about different use cases or applications where it would make sense?
So at the beginning, like when I was coming up with these ideas, I was discussing a lot with my thesis advisors. And then we were thinking like, okay, what are the use cases for this? And that's when we started thinking a lot about tiny devices and the power, like battery powered devices, like drones, for example, where you can't, so maybe you want like a less accurate model, but that is more energy efficient, because that there the battery is the main constraint.
Yeah. Okay, so we got some answers. I think actually everyone answered, and it's pretty clear that it's tiny devices and industrial machinery that's on top.
Nice.
And based on your experience from what we do at Ekkono, what would you say on this?
I think, I mean, this is nice because at the beginning, before I joined Ekkono, I wouldn't expect about industrial machinery. It just didn't come to mind because we didn't work with that. But then after I joined Ekkono, I realized that there are a lot of machines that are not connected to the internet that are responsible for like tons and tons of CO2 and like NOx emissions. For example, gas turbines, that we work with them. So then we realized that if we could reduce the energy consumption of like these huge machines, it could have like a way greater impact than sometimes tiny devices. So I think it's great, the different answers. I was thinking, for example, more sometimes into big server rooms, but definitely there are way more constraints in case of tiny devices and so on.
Sure. And when we've been discussing this the last week, preparing this Open Fika, I've been thinking about a use case too from a more business perspective, because a couple of weeks back, me and our CEO, Jon, had an Open Fika where we talked about how to make money on smart IoT. So that was more oriented around what type of business cases are there when you use smart IoT and edge machine learning. And one very clear conclusion was that smart IoT enables longer relationships with the product after it has left the factory. It also means that companies can start with real data-driven business models, and they can charge for continuous software updates, etc. So like over-the-air updates, adding new features and functionality after a product is already in use and has already been produced. So considering that our models are more energy efficient, that they don't need a huge processing power, they don't need a lot of memory, wouldn't that mean that doing a retrofit of a solution in existing product would be even easier?
I think so. Like, I mean, there's nothing better, right? That when you buy something, then you get updates after, and you're like, okay, at least I don't have like an old product that I bought. So, and I think in the case of energy efficiency, as you say, since it's something related to software, I mean, we can put that directly in the device, right? So we could like make the algorithms better in terms of energy efficient, make them more energy efficient, and then like do this over the updates directly to that. Because I mean, our solutions that we propose, we don't want to change the infrastructure. We don't want you to buy new hardware or anything. We just want to use what there is, what machine, what device you have, and then choose the best algorithm possible for that device and for that use case. And exactly. Definitely like not changing the whole thing.
Yeah, exactly. So I think that's a pretty interesting observation too, that this enables retrofitting in a easier way, more or less.
I think so too. Yeah. Like this is what we see with customers and so on.
Exactly.
It's more like personalized solutions in the end.
Sure.
Because like you learn from each device. So I think definitely has like a lot of advantages.
So I think that we've got fairly a good overview of what energy efficient machine learning is, but if we deep dive a little bit into the technological details.
Yeah.
So how does an algorithm actually consume energy?
Yeah, so I'm going to explain it quite simple. We can go into technical details some other time, or just drop me an email at eva@ekkono.ai if you want to know more. But basically an algorithm is a set of instructions. So do this, do that. And they are meant to be executed in a computer. Anyone can think of it as a program. So those instructions can be computations or memory accesses. And depending on the type of instruction, if it's a computation or memory access, it will consume different amounts of energy. At the same time, the more instructions, the more power and the more energy consumption. So in the end, depending on what your algorithm is doing, it will consume different amounts of energy. The reason is because it's using the processor and the memory in a different way. So for example, if I have an algorithm that is constantly performing memory accesses all the time, it will consume way more energy than an algorithm that is just performing like multiplication, for example. So yeah.
So how for a person who's not technical, but also for all of those who are listening, actually are very much more technical than I am, but how do we measure energy consumption of one single algorithm?
So that's the thing. At the beginning, when I started the PhD, we thought that was the easy part, and then it ended up being the hardest part.
Okay.
Because we thought like, there must be like a million tools available, right? But then we realized like they're not, and they're not that easy because the computer is doing many things at the same time. So how do you account for all of that? So one way is to take one of these physical measurement tools and like plug it in the computer. But then you would need like, to open the computer and so on, and way more in that area.
Sure.
So, I mean, we don't really recommend that. So thankfully, we found like some tools. For example, Intel has provided like a really nice tool called Intel Power Gadget, And what that tool does, since it's from Intel, it has like access to all the processor parameters. It has some like access to some registers in the processor that will count events. So it will count how you're using the processor, what type of instruction, and so on. So then, from what I said before, if we know, how many of this thing I'm doing, then I can estimate how much energy I'm consuming.
Okay.
Is it more or less clear?
Okay. I think that this is an area that really could, I mean, we could spend a lot of time explaining it, because I think that it's the most interesting one, how we really measure it. But as you might know, we usually produce a short white paper after each Open Fika, and I think that we will get more answers on this specific topic in that one.
Definitely.
So I think you mentioned it before, but you focused on decision trees in your research.
Yeah.
Was it mainly around that type of machine learning algorithm, or did you do any comparison between different types? Is it any difference?
Yeah, so like different algorithms consume way different amounts of energy.
Yeah.
We focused on decision trees because they were quite simple and they were quite lightweight. So for example, deep learning, we also tested it and it was consuming way more energy. And then what we have seen at Ekkono is that we don't need to use like the most energy consuming algorithm for all the tasks. That's not always the best algorithm. So basically we don't need to do deep learning all the time. So we adapt to the different needs depending on what we need, and we use different algorithms. And apart from using decision trees, which was my main focus during the thesis, we did a few comparisons to other like ensemble algorithms, boosting, which is also a decision tree, but an ensemble, and like deep learning and so on. And our solutions were usually getting the lowest energy consumption.
Okay. So if we move back to what you do at Ekkono now and what we do, can you explain in a simple way how we build more energy efficient algorithms at Ekkono? And how do we approach a use case, for example, when we think about this?
Yeah, and that's what I really like also. One of the reasons I joined Ekkono is that, I mean, we share the same sustainable mindset. So we try from the beginning to design algorithms that are sustainable and that match the customer's needs. So usually the data scientists like me and our other amazing colleagues and the machine learning engineers, we research which algorithm is best for each use case. We research, one second. Which algorithm is best for each use case. And then we evaluate also like, okay, what is the key thing here? For example, when we are optimizing gas turbines, in that case, like since the turbine is consuming so much power in comparison to the algorithm, we're focusing more on getting like the most accurate algorithm as possible. And then like when our solutions that is already energy efficient reaches the developers, they do all the coding in C++, which is also very efficient, and they try to focus on building the lightest algorithm possible. We don't use external libraries, we code everything ourselves from scratch, which is something quite unique because most of the companies use TensorFlow, but we don't, because we want to provide a lighter library than our competitors. And also, like finally, we constantly benchmark our solutions with other ones, like for example, TensorFlow Lite. And in some experiments that we did, we were able to construct faster neural networks than them, and we were constructing like for the smaller cases. So looking up at the slide that you pointed out there, that was more at Ekkono and more into the algorithm is like, how do we build energy efficient algorithms? That first, we try to find the energy bottlenecks. Energy bottlenecks are that part of the algorithm that consumes way more energy than the rest. And then we focus on that part, and then we try to optimize that part so that the whole algorithm in general consumes less energy overall. That's more or less the summary.
Okay. I think that it's 2:21, so we are a bit over time and we're running out of time. So I would like to try to wrap this up in some sort of conclusion. But before we go into that, if you want to try our software, we have what we call Ekkono.lab, and it's an online Jupyter notebook where you can try out Ekkono. So if you are interested in that after this seminar, send an email to me or Eva, and we will make sure that you get in touch with the right person at Ekkono. So you get a lot for that. So if we would do some conclusions, would you like to share your main insights, Eva, on this topic?
Definitely. So if anyone wants to take some lesson here today, let's summarize that. That is, the goal is like, let's build sustainable algorithms. So whenever we are building a new algorithm, let's focus not only on how accurate it is and how good it is at predicting, but also on how sustainable it is. The reason is already mentioned and is quite straightforward, is that we want to be environmentally friendly and we want to be able to run on tiny devices. If you have an algorithm that consumes too much energy, you won't be able to use it on your phone. And how do we do that? Then, as I said before, we analyze the energy impact from start to end.
Okay, so let's see if there are any questions or if there are anyone who want to raise their hand and ask a question. Do we have any questions from the audience today? I can't see any questions, Eva. I don't know how it's on your side, but I think...
No, I don't see any questions either.
Okay. Everyone's shy today and they're waiting for the short white paper to ask detailed questions later maybe. So let's wrap up. Already next week we will have a new Open Fika, and it will also be a tech edition when Rikard König, our CTO, will talk about federated learning. It will be Thursday, same day and the same time. But the week after that we'll have a little bit of a special edition, because then our CEO, Linn Sidahl, have invited our Japanese partner to an Open Fika session. And since they're joining from Japan, we need to do it before lunch. So it will be at 10 a.m. and keep that in mind. But as always, keep following us on social media. Make sure that you don't miss. And we also post all of our events on our webpage. So thank you all for listening today. And thank you so much, Eva, for joining and answering all my questions.
Thank you, Linn. It was tons of fun.